Hello, this is Joe NE2Z. Let's do a deeper dive on HASviolet. So today what I'm going to do is give you a walkthrough of the clone of the repo you already have cloned on your HASviolet within the HVDN repo directories on your HASviolets. But if you even walk through on the GitHub site itself, here's the tree we have. And you'll notice I'm using Visual Studio Code Editor. Me for editing for any of the code I do in Python. I've worked with Atom. I've worked with all the derivatives of Atom, brackets. Code has been pretty good to me as far as a GitHub integration on it. And I'm not going to go any further on it, but I just wanted to mention that this has been pretty stable for me for Visual Studio Code. So let me go ahead and give you a tour from the HASviolet itself. We have the directories for the information on the antenna, any code that will be contributed would be putting into that folder. The development folder, as I said, you're welcome to wander through it. It's stuff that's under development. Can break things, but just give you a transparency of what we got going on behind the scenes. Hardware, you'll see where I've mentioned of hardware for the Adafruit stack, and things we're actually thinking about for ESP32 down the line. And stable code. Stable is ultimately what you have installed in the HASviolet working directory. And I've walked through each of these files before, but let me give you a deeper dive. And the best way I can give you a deeper dive on this code is actually focusing on the simplest application around receive. So we try to document the code rather well within everything. You might find some old things we've had stragglers as far as comments, but again, I try to lead on that this make everything Python 3 compliant. The libraries we're using the Adafruit SSD library for the OLED. For Python, we're using argparse, board, and bus IO for again access for I2C and SPI. The config parser, so we can parse anything we have for arguments. Curses is for a future where we're trying to do a curses type interface for things. The digital IO, again, that's relative for the interfacing for the I2C and SPI, so we can talk to OLED and the RF module respectively. The RF95, you'll see we're importing the RF95 Pi library. We're actually, that muckety-muck after B31 is actually the specific mode we're putting the modem into, that medium capability of give me reliable data at medium distance. And some other lines we're putting in. Import signal is for my ability to go ahead and actually use some of the signal capability to not only interrupt for transmit during receive, and also to close the program. And that interrupt signal is very important, as we'll get to further down. Importing the settings, again, we're using the config parser. So this is importing anything within the INI file. We just right now have it written for the default section, but we'll be adding future sections as we go along. Import arguments is actually the command line arguments we're importing in. So if you want to do for receive to see raw data or the signal strength, we actually take those statements as arguments, and we keep tab of those. Some of the variables, probably one of the core variables beside what you see being pulled in for the HASviolet INI file, or GPIO node address and frequency megahertz, we reference that. But HASv recipient, we set up that variable for the receiving node we're sending our data to. HASviolet name is where we concatenate or put together the call and the SID to make it the virtual name. Also the header, how we see us tell you that from source to destination, create that as a header, and then the actual payload, which is the header plus the message. So the header for source to destination and the message are actually payload on LoRa payload in itself. The functions, here's the signal handler, so we can go ahead and detect if we want to exit the program and clean up gracefully. Within that function, you'll see how we're actually trying to do the cleanup of setting the RF module, RF90 module, to go idle and do some cleanup so we can shut down properly and cleanly. The next function, OLED display, is exactly that, to deal with how we're doing the formatting into the OLED display itself. And again, the driver we call for that is the Adafruit driver. Setup, again, you'll find these sections common to across all the programs for us doing this setup. We'll go ahead and create the I2C interface. So we're talking to the OLED, as well as down the line other I2C things we need to talk to for sensors. The display setup for the OLED itself. We immediately clear the display. We do a little startup message on the OLED display itself. We set up the signal handler, so if anytime the program is seeing the Control C to go ahead and get out and operate on the signal handlers. And again, we actually go ahead and display the logo itself in HASviolet. Again, there's some code on here that's probably still needs to be cleaned up. The main part is we set up the radio itself, so we're talking to the RF95 module, the chip select, the interrupt, we're setting the frequency, the transmit power, we've initialized the RF95. Again, we want to make sure we have our signal handler set up, and this is the core loop. So what we're doing is, think of it as, if you're into amateur radio, think of it as a repeater. You're always listening for a signal before you do anything. If you don't see anything signal, go ahead and do other things. So right now we have it as, while we are not seeing anything, we can go ahead and just keep looping. But once we see something as far as RF95 available, then we go ahead through the routine of taking the data that's received, also capturing what the RSSI strength is in that data, and we actually do a loop to go ahead and put the data so we can display it as ASCII. And again, these ifs and else ifs are actually dependent on the argument selected. So if you wanted to see just the raw data, or if you wanted to see the raw data and the signal strength, or you just wanted to see the ASCII data and the signal strength, that's what those else if options do. And that just loops, and we just have a final cleanup at the end of the day for display fill, display show for the OLED, and then we shut down the RF95 cleanly. But again, if there's a control C that's done for the signal handler, it goes up to the function for control C and then quits the program, because in essence this while loop is going on forever. The while true makes it go on forever, and while not is for the receive part. So I hope this quick overview gives you a sense. You'll see this common for RX into chat. You'll see this loop, and for transmit it's pretty much straight up. I don't have to do the receive loop. So if I go into transmit, again the same setup for the functions and the config reads and importing and variables. But here for our functions, we're just simply setting up the radio again, clearing the display. And since this is a one-shot where we're going ahead and setting up the radio frequency, we're just sending what was set up for us either in the argument and just sending it out as far as setting the packet, and we print it up on the OLED display itself. And then we make sure we we do that cleanly. Chat has an additional signal handler needs to be done. Since we're not, and I defer to the experts on this, since I got no way of, the only access I have is the two signal handlers, which is control C and then I think it was another control signal. I can use the control signal to go ahead and put us into transmit mode. So if I go to the main loop, you'll see that here we set up the radio, and here's why I set up for if there's sig TSTP, put us into send, which would be a control Z. If there's a control C, we go ahead and exit. This was the only mechanism within chat I can go ahead and actually get us to a clean transmit mode, because the challenge is this: there is no buffer coming in from the Adafruit module to the program, to the user's program space. There's no hardware buffer. In fact, you would need a hardware buffer to queue up anything that's being signaled to go ahead and run all the various other subroutines you want. So we actually have to always be in receive mode and actually do a signal to cut us out to send something we want to transmit and then jump back into the loops again. So I might have given you a fire hose of information, but I encourage you to read through and look through the code where it's documented. And again, we're always open to any and all feedback. Again, I hope this was very helpful. Thank you very much for your time and attention, and I hope you enjoy HASviolet.